All right, as we move on, we're going to talk about Chapter 3, Section 4, Linear Programming. Now, linear programming is new. Everything we've done so far has been review of Algebra 1. This will be the first new item that you see so far. Linear programming helps us to minimize and maximize profits and costs. So this is really the application of inequalities. If you want to write that down, this is the application of inequalities. And there's the standard that we will be meeting. All right, we're going to start off slow with just a basic math problem, and then we'll move into more of an application problem. Vocabulary. If I ever say the word constraints to you, it's like me asking you, what are the limits? Or what are the restrictions? Linear programming is a method of finding a minimum or a maximum. And that would be of some type of quantity. And it's all based on, the min and max is all based on our limits or our restrictions. Now, what kind of problem am I talking about? Let's think of, like, if you ever go out into your own business, let's say that you're going to be a cook or a baker. You want to limit your costs. You want to minimize your costs, but you want to maximize your profits. Your limits would be things like, how much flour do you have? How many eggs do you have? So your limits are literally, what are you limited to? And your mins or max are usually your minimum cost to you and a maximum profit for you. The feasible region it's simply the graph of the systems put together. The objective function is the model of what you are trying to either minimize or maximize, and it all depends on what your problem's about. In problem 1, I will walk you through how to just do it using math, and then we will apply it to a real life example. Please take a moment, read over these steps. Here, I'll read them to you. You make sure you always solve for y with your constraints, okay, and this is for your limits. You make sure you find the vertices, the xy points where they cross. There may be 3, 4, there might only be 2. Find all of them. And then you're going to plug each of these vertices back into the objective function. So if you could watch through problem 1, and then we'll apply it on problem 2. Hi guys, I'm going to walk you how to solve problem 1 in section 3-4. Now section 3-4 is about linear programming. Problem 1 just kind of gets you into the heart of the lesson and teaches you how to do a couple of things with linear programming. And we'll get to more of the application problems and stuff later. But first you need to learn just how to kind of manipulate the equations, where to graph, and things like that. I do have some steps above for you. These are the steps that I'm going to find. Now our goal is to either maximize or minimize something called our objective function. We'll teach you later how to make an objective function, but if you look at problem 1, they give us the objective function, and it's p equals 2x plus y. We're going to save that objective until step 3. So let's take a look at the different constraints that we're going to have. Now, if you were in a different problem, in like a real life application problem, you might have constraints, like how much money you have, how much time you have, how many things you want to make. And then you would make these equations, but right now they're just given to us so we can learn how to do it ourselves. We're going to graph each of these constraints. So let's call them 1, 2, 3, and 4 because there are 4 of them. And let's talk about number 1. We got to solve this guy for y. So we have x plus 2y is less than or equal to 5. Take the x over. So if 2y is less than or equal to negative x plus 5, I'm doing nothing new to you guys. We're just solving. And you get y is less than or equal to negative 1/2 x plus 5 over 2. The next constraint we're going to graph is number 2. X minus y is less than or equal to 2. And take the x over, so we have negative y is less than or equal to negative x plus 2. And then we're going to switch the negatives out, so we're going to get y is greater than, remember to flip your sign, positive x minus 2. And then 3 is x is greater than or equal to 0. That's just going to be a straight up and down line. And then 4 is y is greater than or equal to 0. That's just going to be a straight left and right line. We've already graphed the straight up and down line and the straight left and right line. Now let's graph the others. Y is less than or equal to negative 1/2 x plus 5 over 2. Just so you know, 5 over 2 is the same thing as 2.5. Then I'm going to go up 2 1/2 and make my y-intercept. I'm going to go down 1 over 2. Look how I'm in the middle of my boxes since my y-intercept was by a half. Down 1 over 2. Down 1 over 2. Get a straight edge and connect. That is line number 1. Line number 2. Y is greater than or equal to x minus 2. So I'm going to plot my y-intercept by going down 2. Then my slope is 1 over 1. Notice it does hit exactly at a dot on the other line. We're hoping that happens for the rest of the lesson today. Connect. So we've graphed, now we need to shade. It should be below line number 1. It should be above line number 2. This one's line number 2. And it should be bigger than x equals 0 and bigger than y equals 0. All of those constraints fit inside of here. No, they will not always fit in the left part of the graph. People make that assumption. It's not right. Always check all of your shading. Okay, guys. So what are we going to do with this area here? You're going to pick test points. So, if you look at step 2, we solved them. Step 1, we solved them and we graphed them. Step 2, we need to find each vertice. Okay, the vertices are the corners. The first corner I see is right here. That happens at 0, comma, 2.5. And these are just the corners of your shaded area. Here's the next vertice. It happens at 3, 1. We can label these. Next, we're going to look at 2, 0. And the last one, 0, 0. So I have 4 vertices that need to be tested. Now I'm going to test those in my objective function. Again, you'll have your own objective function when it comes to word problems. They're giving it to you. There's the objective function. I told you we were going to save it until the end. So it's 2x plus y. And our goal is we're to find the points, and we're going to, here it is, maximize the profit. Sometimes you'll minimize. This time we're maximizing. Let's plug in 0 for x, so we get 2 times 0 plus 2.5. When you multiply that out, because I'm plugging it in for x and for y, we will end up getting 2.5. Now let's plug in 3, 1. So I'll do 2 times 3 plus 1. That's 2 times x plus y. That's 7. Then I'll do 2 times 2 plus 0. That's 4. Again, I plugged in for x and I plugged in for y. Then I'll do 2 times 0 plus 0 is 0. There is a clear maximizing, and it happens at 7. Here's what you are going to state. The point 3, 1 maximizes the objective function to 7. That's because it happened at point 3, 1, and 7. A quick overview. We graphed each of these. We found out where to shade. We found the different corners. And we tested the different corners into the original objective function. We will apply these to things like maximizing a profit, minimizing your time, minimizing the cost to yourself on the next couple of examples.